Welcome back to the Hello Tomorrow Global Summit. For this next talk, it is my pleasure to welcome to the set the CEO and co-founder of Hello Tomorrow, Arnaud Delatour, and he will be joined by Massimo Portincaso, who is the managing partner at BCG.
Hello, Massimo. Really nice to talk to you and to have this discussion with you, because not only are you co-leading BCG activities around deep tech, but you're also my partner in crime in always trying to push further our understanding of the deep tech revolution. And we love to share what we find out, usually through some reports. We publish several every year. So today we are going to do that, sharing what we found out together at the Hello Tomorrow Summit. So really excited. And actually, I realized I never asked you this question. You were before focusing on deep tech for BCG, managing and leading the marketing activities for this global management consulting firm. So how do you go from marketing to leading deep tech?
Well, I think that the question should be in the very first place, how did you end up doing marketing? But that's a whole different story. The truth is that I'm an engineer at heart, and actually working with you at Hello Tomorrow, but also being around at MIT Media Lab, I just really realized that there was something going on, and a big shift was just about to happen. And we were just about to see a transition from the world of bits that was characterizing the last 2 decades. We were moving to a place where bits and atoms were coming together, and realized that this was something quite big. And basically, this was the incipit of deep tech. And realized that this is something that is really important, and wanted to get engaged, and want to help shape it and really take it out of the niche and make it mainstream, because the potential of the impact of deep tech is simply huge. So ultimately, it's a little bit of also your fault that I'm here. And this week has basically confirmed this feeling of the importance of this, seeing all the finalists and all the participants, a great keynote speaker. So I'm really looking forward to talk about this, and thank you for having me here.
Happy to have induced this transition, and it's true that we get the feeling that something is going on, and it's changed a lot since the creation of Hello Tomorrow 10 years ago. At that time, startups were mostly about digital platforms, mobile apps. To be successful, you had to create a new digital marketplace. It was all about the next Uber of something. And a few years later, in 2016, when we wrote the first report using the name Deep Tech, from tech to deep tech, we felt that the revolution had already started. So we felt we needed this kind of symbol, so a new term, a kind of symbol for people to take notice of this revolution, but also, I think, a banner also for the leaders, where there are startups or corporate leaders or investors, scientists, so for the leaders to find each other. And I think maybe it's pretentious, but I think it worked. And I think now those leaders, they feel they found their tribe.
Absolutely. I think that definitely Hello Tomorrow was part of this, I would say, almost a revolution and a reaction to the mainstream. I think it was a reaction to the next, and I was surprised to hear from Seth Bano yesterday that we're still funding apps to order food for dogs. I think that the word is served. I mean, they are, of course, they have their legitimacy, but I think it's really important we start moving this forward. And before we go into the discussion about deep tech, I would really love to talk about one thing that I get a lot of questions about. To say, Massimo, is this technology deep tech? Is this a deep technology or not? And I think what is really important that we all realize is that it's not about the technology itself. There are emerging technology, there always will be emerging technology, but I think it's really important for all of us to understand that what really deep tech brings to the table is a different approach to innovation that makes the possible impossible. And we have seen in many of the talks during the week.
Yeah, actually, it reminds me a little bit what we used to say a few years ago about deep tech. It's true that we were focusing a lot on the technology, the fact that it takes more time to reach the market, it's more expensive, but in the end, I think it does justice to what deep tech really is about, to focus on the technology, but it's really more about what it can do, all the new opportunities, and also the new approach that we need to grasp those opportunities.
Yeah, and I think it's really important that we understand this to be able to understand the reach and the impact that can be made through deep tech. And actually, if you look at it from a kind of what are the components that really make it, I mean, it all starts with the lowering of the barrier to innovation. We just heard before Michael from Lanza talking about the fact that some of this stuff was not possible, what Lanza is doing today 10 years ago. And this is true for many, many things. So what we have seen is that the rise of platforms have allowed many things. On the one side, cloud computing, but also what is happening with the next generation sequencing or the CRISPR platform and many others. So these happen. The cost of hardware has gone down a lot. What hardware can do has increased tremendously. Data are more accessible. And also we have seen a little bit of increase on the capital available. It's still by far not enough to fuel this, but this has allowed really lowering the barrier to access that then have triggered a very important component. And this is, in my view, one of the things that really characterizes deep tech, because we have two main convergences that are happening at the same time. And on the one side, what we're seeing is that domains that used to be very separated are now coming together into one place, into a single startup, which is one of the big novelties. So we had a strong science at the foundation of all of it, but we're seeing that this is coming together with a strong problem orientation, or call it design thinking problem orientation, but really, okay, what is the problem that we're trying to solve, and how can we use the science to do this? And then we have engineering coming together to build a bridge between the two. And I think that Cellino, which was one of the examples that we saw at the beginning of the week on Monday, is a fantastic example of those three domains coming together in one single startup. So you have the question and the quest for regenerative medicine on the one side, how can we use stem cells? On the other side, the science of stem cells and the capability and the technology to turn adult cells into stem cells. But then you have the engineering building the bridge between the two, making it possible at scale, which is something that was simply unthinkable a few years ago. And this gives you an idea of through this process how we can start to regenerate retina and other parts. And out of the three, I have to say, one might think that the science part is the most important. I would say this is definitely the necessary condition, but it's not sufficient. And what we're seeing is that one of the big turn which is happening is with the focus on the problem orientation. And what this is triggering is the second convergence that we're seeing. What we're seeing is that startups are not in the place where they have one technology and they try to find a use case, as it has been the case very often in the past. And we have heard from the professor from EPFL that was saying this is the main reason why startups fail, because there is no market need for it. We're seeing that this problem orientation is becoming very important. And what is happening is that the startups are bringing together the different technologies that leverage the advances on the digital side to do this. And they're able to do things that were unthinkable before. If you go back to Cellino, what is happening, what they're doing is that they have the technology, the biology of turning the adult cells into stem cells. But what they're using is laser physics and machine learning to be able to make it at scale. And this is the big difference that we're seeing. And this is one of the way we're seeing really the potential. So a new approach, convergence of approaches, which is leading to overcome barriers, unlock constraints, and make what used to be impossible possible. So I think this is in essence what we're seeing right now.
And it's really interesting also to see that this is confirmed, and that you mentioned one of the keynotes of the week. And actually, one of the positive side of being able to, we had to switch to a digital format. We are now virtually connecting all over the world. But one of the positive consequences is that I've been able to follow a few keynote and startup pitches. So it was really great to see that what we are talking about is not only nice theories. That's actually what we see in successful startups. And really the moment when I felt that was yesterday morning, listening to Nora's talk about her startup, Neuritas. What she's doing is basically trying to find new molecules to tackle important human health issues. And she really used this new approach. So instead of using serendipity, because the traditional approach she was talking about was that we start from the trillions of molecules. She gave the example of an apple. I won't redo the whole talk, but basically, the traditional approach is to start from the trillions of molecules, then do a kind of random test and learn, and then eventually you find one molecule that have a nice, valuable impact on the human body. But the problem with this approach is that it takes decades. It's very expensive because it is long, and the approach she's using and she described is really the reverse and exactly what you were talking about. So she does start from the problem, so the consumer needs. So what are the most pressing issues related to human health? And then she uses her understanding of how proteins interact with the body to kind of design what should the right proteins molecules look like. And then she does the lab work to eventually find those proteins. So as you said, she does start from the problem, or it's kind of design thinking as you described. And she also used the convergence of several technologies. So the proteomics, or the science of proteins, so to understand how the protein fold, how they interact with our body, but also artificial intelligence to make sense out of the huge amount of data that is produced during those lab manipulations. So it's and it's incredible the outcome of this new approach, because instead of several decades she is able to find a new molecule from the idea to the molecule on the market in 2.5 years. So that's really a difference of an order of magnitude. So you can imagine the incredible consequences that it will have on our healthcare.
Absolutely, and I think we're using Sedino, Nora. Example, one might think that it's only about biology, but actually one of my favorite examples of the power of deep tech is when we use another keynote speaker from Hello Tomorrow from last year, which is Commonwealth Fusion System. And they're a startup based out of Boston, and they're working on nuclear fusion. So imagine this, nuclear fusion, something that we started talking about in 1958. We've been always saying is 10 years out. So basically, it's never going to happen. It's such a complex problem that 35 countries have come together in a consortium called ITER with a budget of 20 billion starting in 2006 and planning to get there to some net result in 2035 or 2040. And then you have on the other side a startup out of Boston, funded in 2018, who plans to get to a net gain plant producing energy utilizing nuclear fusion in 2025. And how is it possible? You have on the one side 20 billion, more than 30 years to get there, and then a startup with 35, 40 people and a budget of 200 million. And I think this is really simplified, or is a very good example of the power of what we're talking about, and what can really be made possible. Of course, we don't know yet if they're going to be successful. They claim they're going to be. And the latest New York Times article said that they have good chances of doing it among all the many startups that are working on nuclear fusion. But the point is that if you really look at what they're doing, this is really when it becomes stunning. Because the moment we got the breakthrough in the approach toward nuclear fusion has been when we stopped treating nuclear fusion as a physics item, but really when we said, okay, how can we build and design a plant to produce energy and attach it to the grid? And this is triggered, and this is the problem orientation I was talking about. And you bring it together with the science of nuclear fusion, and then you really need to connect it with an engineering so that you really build a plant. But the interesting thing is that the great breakthrough that they made was not in terms of physics of the plasma coming out of the fusion, but when they identified the material, a high temperature superconductor that was allowing them to double the magnetic field to steer the plasma, to contain the plasma, to make the plant economically viable. So you see, it's again the convergence of technologies. You have the plasma physics, but you have materials technology, and also, of course, some computation helping to make this happen. And this is really another example. But what becomes really interesting, to go to your point about the time, is that what they did, and this is one of the peculiarities, that we have seen with Commonwealth Fusion a bit of the adoption from deep tech startups of the lean startup methodology. So they started to iterate, to build, measure, and learn. And they really went through quick cycles so they could iterate and learn. And if you look at their plan, they have a proof of concept, they have an MVP, and they plan to launch in 2005. And they have a very strict plan how to get there. And this has allowed them basically to compress cycle that normally would have taken 1 year into 1 month. And this accelerate a lot the process and make the thing, the interesting thing that we're seeing is that it's not only what is possible, but how fast what is possible is made possible. And this is something that is really, really characterizing what we're seeing in deep tech right now. So, and last but not least, they've been bringing on board a whole ecosystem with university companies, venture capital, to be able to do this. So again, we don't know if they're going to be successful. I think they have very good chances of doing it, but it really shows you the potential of what can be achieved through deep tech.
So I see that you're now a nuclear fusion expert, and I think we both agree that so this is a revolution. Well, I knew that we already agreed on that, but I hope the people watching us are already convinced that this is a revolution, and there is a new approach also that we need to have to kind of be a leader in this revolution. Being where we are working with many different companies in several sectors, so we see that the impacts are really broad. So what excites you the most?
About deep tech, I would say it's something that you can see almost as a kind of a fil rouge across the week. It started on Monday, and today and yesterday was very, very, very clear. And it was in the presentation of Michael from LanzaTech talking about what biology can do. It was in the presentation of Heike yesterday when he was talking about nanoparticles and how can use nanoparticles on Nora presentation. You are seeing really a major, major shift that is happening that is really exciting. And I'll explain in a second why. But basically, what we're seeing is what we're calling nature co-design. And very often when I say nature co-design, people say, Massimo, we've been designing with nature for centuries. So what's new? And I think we really need to be careful because there is a paradigm shift that is really happening. I know that consultants are accused to use jargon and hyperbole all the time, but I think in this case it's really appropriate to talk about a paradigm shift that is happening right now, because this is not about partnering with nature like we've been doing with farming and agriculture. It's not about biomimicry, getting inspiration from nature. This is what is happening now, is that for the first time in the history of humanity, we are in a position to start using nature as an engineering and manufacturing platform. And this is exactly what we're seeing from Lanza, what we're seeing from Nora. So we can really shift, and it's not about partnering, but is really using what nature has developed over billions of years, which is highly efficient, to do what we want it to do. And basically, the shift is from starting and designing things at a certain scale. We can now operate at a nanoscale and build things from the ground up. And this is a huge shift that has a big set of consequences that come with it. Because basically what we're doing is that by doing so, we bring matter and to a certain extent energy into the innovation equation that is something that was not possible before. So we have now the possibility to change something that was considered as a given into a variable into the innovation process. And this opens an incredible set of opportunities that we have. And also by operating this way, we can, to a certain extent, reverse something that it started with the second industrial revolution. In the second industrial revolution, one of the main things that we have done is that we started basically exploiting nature, if you want, to a certain extent. One example is oil. We started putting a lot of energy to extract oil from the ground, to then add additional energy to break oil down into different components, and to then use it either to produce energy or to do and produce stuff. Now we can completely bypass that cycle, and we can directly work with organisms to produce what we want to produce. We can bypass, if you want, the cow, and we can start producing the meat directly in a way which is way more efficient than it is with the technology of the cow, if you allow me the comparison. So it's really a big shift that we're seeing, and because energy has perfected its process, because nature has perfected its processes over so many years, it's very efficient. It mostly operates at a room temperature, at room atmosphere, and it has a lot of advantages compared to the way we've been doing stuff so far. What needs to be clear to us is that we're just really at the beginning of it, and we still don't know much. We need to learn how to do it, but I think there is one example that I love that really exemplifies the power of what we're doing. If you look at, for instance, at fertilizers, we need nitrogen basically as a fertilizer. And the process that is used today is the same process that was invented in 1908 by two chemists, Aber and Bosch. And this process is used to produce nitrogen that gets distributed to plants. This process alone is responsible for between 3 and 4% of overall greenhouse gas emissions. It's almost as much, I think it's exactly as much as the whole of aviation. So one thing, ammonia, nitrogen, fertilizer produce as much as the whole aviation. And this process is started to be responsible for 2% of the overall energy consumption in the world. Now, we haven't been able in 100 years to come up with a better process. We're still using it. And if we apply nature to design to it, this gives you an idea of the difference we can bring, because what if instead of producing ammonia and producing this fertilizer, we design bacteria that allow us to fixate the nitrogen directly on the roots of the plants? And this is what different startups are doing. It's a joint venture by Bayer and Ginkgo Bioworks, Pivot Bio, Kula Bio are working to do exactly. And you can completely change the way you're doing. You don't need to put all that energy to produce these. You can work with microbes to do that directly on the roots of the plants. And this gives you an idea of the whole power of nature to design and why I'm so excited about it.
Yes, it's definitely going to impact whole value chains. And one of the ways it's going to impact it is that what we consider today as really value chains, not always linear, but it's going to really become more like value nets, and some things that today are considered as waste will become the feedstock for other processes. And we've seen several examples this week with one of the worst waste we can think about, which is carbon dioxide, so the CO2 from the air, which is responsible for climate change. We've been trying for quite some time to do some carbon sequestration, so to capture the carbon from the air and then store it. But the problem with this approach is that if you only store it, then you don't have any revenues from it. So you need to rely on a kind of carbon tax for it to be profitable. But the new trend that really we saw this year is that many companies are working to not only capture and store it, but actually upcycle it, so transform it into something valuable. Actually, it was 1 hour ago. That's really the project of LanzaTech, and it's not only a project because what they announced recently is that they managed with working with Total and L'Oreal to use CO2 as raw material to build plastic packaging. So that's, I don't know, I find that quite incredible. And so going beyond this specific example, we saw many other examples doing the same thing, maybe not for packaging, but for example, one of the finalists from the environmental track, carbon upcycling technology, they use some powder to capture CO2 from the air, and then they use it to improve the capacities, well, they improve construction material. And another one, the winner from the energy track, Agora Energy Technologies, I think that's their name. They actually use CO2 to build batteries. So the CO2, what used to be and is still today, I mean, we shouldn't be too much into the future, but CO2, what is today one of the worst outcome and waste of our industry, is kind of becoming the center of a value net and being transformed into valuable products. So it is the case with the examples I mentioned for plastic, so it can be transformed into plastic, into construction material, into batteries. I know other projects also doing that to build clothes, to build fuel. So I mean, the impact, if we think about it, is really incredible.
No, it's absolutely incredible. And I think one of the things which I think is very important for us to realize is that, yes, it is a great opportunity for the planet, but it's an incredible business opportunity. And I'll quote Al Gore here. He said in Wired in July that he said, this is the biggest business opportunity in the history of the world, and it's the biggest investment opportunity. And I very much agree with him. If you do the math and you look at the value chains that are being impacted by this, we're talking about 40% of the global GDP. We're talking about something like 30 trillion. So it's a huge opportunity. And by enlarging the option space, we can leverage the precision that comes with it, building from the atom, and create better solutions that allows you to deliver products that are better than the one that are coming, and you can completely shift the value pool. So I think this is a very, very incredible opportunity. But by all excitement, I think that we also need to consider a little bit the other dimensions, because we need to really avoid the mistake that we've done in the past of looking at things in a reductionist way. And we need to look at it in a non-reductionist way somehow. So what is really, really important is that from the very beginning, we start thinking about the second and third order consequences. What we absolutely should avoid is the fact that we start doing it, or we have the same situation that we had with the second industrial revolution, when we start burning fossil fuels without realizing what is going to cause down the line. We need to avoid a situation in which we have social media, but we don't think about the second and third order consequences of what this is going to have. So I think it's very, very important that we have a non-reductionist mindset, and that we start from the very beginning thinking about the emergent properties of what we're generating. We need to have an ethical discussion about it. But I really love what Owen was saying early on today about this idea of a chief Anthropocene officer. I think it's really important. I think this figure that he was talking about is, for me, the symbol of this necessity to think about the non-reductionist dimension, the second and third order consequences from the very beginning. If we look at those down the line in 20 years, it will be too late. We need to think it through now without stopping it from the beginning.
I totally agree. It's really important. And I think another reason why it's important to anticipate the potential consequences and being transparent about that is that if we don't do it, if we don't do it, it won't trigger a conversation with society, and we need to trigger this genuine conversation because otherwise it creates some irrational block. We can see that, for example, with the nuclear industry, because nothing is black and white. All the technologies, the applications have bad and positive consequences. And if we don't have this discussion openly, I think people will focus more on the bad consequences because fear is more powerful than hope. I think that's the natural mechanism that also have been selected by natural evolution, because it helps us survive more than hope, fear. So if we don't have this open discussion, what we will end up having is that as a society, we will create more negative imaginaries. And once they are here, those negative imaginaries, it's very hard to come back from them. We can see that for the nuclear industry. We can see that for GMOs. We can see that for vaccines. So it's very important to have these discussions. I'm not saying that they are all good, and I'm not crazy about technology. It's just we need to have this discussion, and that's really what we want to do. Also with Hello Tomorrow and including with the Hello Tomorrow Summit, fostering those open discussions and including as many people as possible, so that the choices we do, they represent the whole society and not just a bunch of experts. So I think we are committed as a team also to keep doing that in the years to come. I see that we are, I think, coming to an end of this session. It's been a very nice discussion. I don't know if you have something to add, Massimo?
Just to close, to build on what you were saying, I think it's really, really important that we have, as we were talking about the dialogue, that we bring on board also the emotional side. It would be a major mistake just to argue with facts. And with science, we need to have this dialogue. We need to get society on board. We have a huge opportunity to undo some of the stuff that we've done. We have a huge opportunity to build a better world. We all need to work toward that and not forget the emotional side of things. That said, I would love really to thank you and the Hello Tomorrow team for this great event that you organized, which I think is a very important part of this dialogue that we're doing. So thank you for it.
Thank you, Massimo, and looking forward the future of our relations and or everything that remains to be found.
Okay.